Hello, everyone. I'm Mackenzie Geisel.
I'm Jacob Perry.
I'm Josh Peterson.
And I'm Micah Angus.
And our project is the TPRC. The TPRC is a toilet paper roller and cutter. This mechanism rations the perfect amount of toilet paper, rolls it out, and cuts it for use.
This mechanism utilizes two different sorts of mechanisms. It uses a 4-bar to translate rotational motion from the motor into a harmonic up and down motion, which then translates to a up and down motion for the cutting of the toilet paper.
So for the acceleration and speed of the TPRC, the acceleration should be as quickly as possible for convenience, but slow enough where the paper goes through the cutter without folding up. Through careful testing, we determined that this is about 2 radians per second for single ply, or about 3 radians per second for double ply. While at first glance, it might be assumed that maximum acceleration is directly correlated with the number of plies, air resistance, which depends on the velocity squared, is the determining factor on folding. And while strength increases pretty much linearly with plies, the coefficient of resistance in the air remains roughly the same. With speed, similar to acceleration for the TPRC, it should unroll as quickly as possible for maximum convenience, but not too quickly where it would bunch up from the air resistance. Due to the short duration of operation, the TPRC spends most of its time accelerating or decelerating.
So for the graphical and analytical analysis, we use Mech Analyzer to compute the graphical analysis. For the analytical analysis, we looked at our 4-bar mechanism from our prototype. When theta 1 was 0 degrees, we measured that theta 2 was approximately 40 degrees. Then using a vector loop equation, we broke the equation into its real and imaginary components. Having the two equations and two unknowns, we solved for theta 3 and theta 4. We then took these calculated angles and went to our model and compared the calculated angles for theta 3 and theta 4 to the measured angles from our prototype for theta 3 and theta 4. We saw that the measured angles from the prototype and the calculated angles were very similar. We also saw that in Mech Analyzer, the graphical analysis gave us the same angles, which we can conclude that our mechanism functions as it should.
So for the prototype, the model is designed to be simple and accurately show the defined motion path for a mechanism. The silver pin on the model is the attachment point or the axis for the toilet paper roll, and the chopping arm demonstrates the cutting motion of the blade. While changed slightly from the CAD model to be more 3D printer friendly, the fundamental link dimensions remain the same.
The 3D model was designed in SolidWorks. After the basic geometry was created, the solid bodies were designed around that. In addition to adding a motor that you can see on that red box, which has a button for electronic control, this utilized basic constraints. That way the motion would be realistic to how it would act in the real world.
The toilet paper roller and cutter is incredibly useful with its rationing and hands-free abilities, and is a mechanism that is able to be installed anywhere from businesses to homes. With multiple acceleration settings for preferred ply and an easy-to-use design, the TPRC provides an effortless, efficient, and convenient way of cutting toilet paper. Thank you for your time.